Hello everyone. Once again, welcome back to Academia Science Tutoring. In the last session, we have seen the arrangement of resistors in a circuit, the different methods in which resistors can be arranged, and we have seen how to the equation to find the effective resistance in a circuit in both series as well as in parallel combinations. So the important thing that should be in mind is that in a series connection, the potential get divided and the current will be the same through each resistors, whereas in parallel connection, the potential will be the same across the resistors while the current will be getting divided in a parallel circuit connection. So, and we have seen the equation to find the effective resistance. In a series connection, it is R is equal to R1 plus R2 if there are two resistors, and in parallel connection the effective resistance is R is equal to R1 R2 by R1 plus R2. So keeping these ideas and equations in mind, today we will solve certain numerical examples. Here is the question: what is the current if 4 ohm and 2 ohm resistors are connected in series and 6 volt potential difference is applied? So in the question it is given that two resistors, what are the values? 4 ohm and 2 ohm resistors are connected in series. So let us draw the circuit. A 4 ohm and a 2 ohm resistors are connected in series, and what is given? With a 6 volt potential difference. So the source voltage is what? 6 volt. So we will connect a cell, a 6 volt battery. So the circuit will be like this: 4 ohm and 2 ohm resistors connected in series and a 6 volt potential difference is applied in the circuit. So what is to be find out? What is the current in the circuit? So the current in the circuit should be find out, and current, to find the current we'll use Ohm's law, that is I is equal to V by R. I is equal to V by R. We know the potential difference V here, that is 6 volt. Then R is the effective resistance in the circuit. So we have to find the effective resistance in the circuit. Since these two resistors are connected in series, what is the effective resistance? R is equal to R1 plus R2. That is 4 ohm plus 2 ohm, that is 6 ohm. So this is the effective resistance in the circuit. So now we can easily find the current in the circuit, that is I is equal to V by I. So V is 6 and resistance, effective resistance is also 6. So we get this as 1 ampere. So the current in the circuit is 1 ampere. Next question: what is the current if a 12 ohm and 4 ohm resistors are connected in parallel and 12 volt potential difference is applied? So in this question, a 12 ohm and a 4 ohm resistors are connected in parallel. 12 ohm and 4 ohm resistors connected in parallel, and a potential difference of 12 volt is applied across the circuit. So let's draw the circuit. A 12 ohm and a 4 ohm resistor connected in parallel, and what is the potential difference? 12 volt potential difference is applied. So The circuit will be like this. And again we have to find the current in the circuit by using Ohm's law, that is I is equal to V by R. So this V is the potential difference, that is 12 volt, and R is the effective resistance in the circuit. So we have to find the effective resistance in this parallel connection. So we know the equation, that is R is equal to R1 R2 by R1 plus R2. So substitute the values here, that is 12 into 4 by 12 plus 4, that is 48 by 16, which is equal to 3 ohm. So we get the resistance as 3 ohm. Now let's find the current, that is I is equal to, we know that potential difference is 12 and we find the resistance as 3 ohm. So we get this as 4 ampere. So the current in the circuit is 4 ampere. See the next question. Here we have a circuit. In this circuit we can see that 3 resistors of values 30 ohm, 10 ohm and 5 ohm, they are connected in parallel, and a source voltage of 6 volt potential difference is given. So the question is to find the current through each resistor. The next question, find the total current drawn from the battery, and the third, we have to find the effective resistance or equivalent resistance in the circuit. So take the first question, find the current through each resistor. We know that in a parallel connection, the current will get divided at the junction or not. Here the current get divided as I1, I2 and I3. Okay, so we have to find this each current, that is I1, I2 and I3. So we'll use Ohm's law to find these current. So we can write I1 as V by R1, which is 6 by R1 is 30. We get this as 0.2 ampere. The next current I2 is equal to V by R2, which is equal to 6 by 10, that is 0.6 ampere. And again I3 is equal to V by R3, that is 6 by R3 is 5, which is equal to 1.2 ampere. So now we get the current through each resistor as I1 as 0.2 ampere through the resistor 30 ohm and 0.6 ampere through the resistor with value 10 ohm and 1.2 ampere through the resistor R3, that is 5 ohm resistor. So we have solved the first question. What is the next question? Find the total current in the current drawn from the battery. So the total current is current I, that is I1 plus I2 plus I3. That is the total current I is equal to I1 plus I2 plus I3, which is 0.2 plus 0.6 plus 1.2. That is equal to 2 ampere. So we get the total current drawn from the battery as 2 ampere. And the next question is to find the equivalent resistance in the circuit. So we know the equation to find the equivalent resistance in the circuit. That is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 by 30 plus 1 by 10 plus 1 by 5. By solving this, we get 1 by R is equal to 1 by 3. Therefore, the effective resistance R is equal to, taking the reciprocal, 3 ohm. So the effective resistance in this circuit is 3 ohm. Now, let's find the effective resistance of this circuit. See, here 2 resistors, 6 ohm and 6 ohm, they are connected in parallel. See, both ends are connected. So, these 2 resistors are connected in parallel, and this combination is connected in series with another resistance, that is 6 ohm. So, how we will find the effective resistance of this circuit? First of all, take this part and find the effective resistance of this parallel connection, and then find the effective resistance or total resistance of those two in series. So, first of all, find the effective resistance of these two. That is R parallel is equal to R1 R2 by R1 plus R2. That is 6 into 6 by 6 plus 6, which is 36 by 12 is equal to 3 ohm. So, the effective resistance of this parallel connection is 3 ohm. So, we can redraw this circuit as, this is a 6 ohm resistor here, and then the effective resistance of this can be drawn like this. That is, we get this as 3 ohm. So, this circuit we have redrawn like this. So, next, to find the effective resistance, we know that the 6 ohm and 3 ohm resistors are in series. So, it's easy to find the effective resistance as R effective is equal to R1 plus R2, which is equal to 6 plus 3, that is, 9 ohm. So, the effective resistance of this circuit is 9 ohm. Now, check this circuit. We can see that this 6 ohm resistor and 6 ohm, these two resistors are connected in series, and their combination is connected in parallel to another 6 ohm resistor. So, how to find the effective resistance of this circuit? First of all, find the effective resistance of these two resistors connected in series. So, we get this as R is equal to R1 plus R2, that is 6 plus 6, that is 12 ohm. So, the effective resistance of these two resistors are 12 ohm. So, we can easily redraw this circuit as, so here we get the effective resistance as 12 ohm, and then we have a 6 ohm resistor here. So, we can redraw this circuit like this. So, this 12 ohm is the effective resistance of these two resistors, and this 6 ohm resistance is drawn here. So, now this 12 ohm resistor and 6 ohm resistors are in parallel. Now, find the effective resistance of those two. That is 1 by R is equal to 1 by 12 plus 1 by 6, that we get as 3 by 12. Therefore, R is equal to 12 by 3, that is 4 ohm. So, the effective resistance of this entire circuit is 4 ohm. Hope you understood the questions that we have solved today. If you have any doubts regarding this, please feel free to comment in the comment box. I'll give you the answer for those. Please share, support and subscribe my channel. Thank you.